Hey, how's it going everybody? And welcome back to Michael Workspace. I am Michael, and in today's lesson, we'll be going over another LeetCode problem. And it's a pretty popular problem here. It's called 2-sum, and it's a rated easy problem, but it is the number one ranking question that is asked at an interview. So this is you're likely gonna run into this at at one time or another when you get go to for a tech interview. It's actually been asked at huge tech companies such as Google and Facebook. So yeah, definitely memorize it and try to understand the algorithm here. So let's go ahead and look at the problem statement. All right. Okay. So let's see if I can make this a little bit bigger. Okay. Let's read through this now. Given an array of integers, return indices of the two numbers such that they add up to a specific target. You may assume that each input would have exactly one solution, and you may not use the same element twice. Okay, so that's a pretty important hint. Let's take a look at an example here. So given this num list, 2, 7, 11, and 15, and our target number is 9, and because nums at indices 0 and 1 refers to 2 plus 7 equals a target of 9, we want to return its indices within a list. Okay, so within a list. All right, so right off the bat, I can think of a couple solutions here. The first one is a brute force solutions, and it's an n square time complexity, and it requires using nested for loops. And so for each element in the list, we'll be looping through the entire list again, or the length of n, to look for its complement, look for another value that when added to the current element equals a target. So that takes n time, but with the nested for loop, the operation is gonna be dealing with the n square time complexity, and the space is still constant, so that's good. But the n squared time complexity might be a deal breaker for very large data sets. All right, I'm just gonna go ahead and code that up, and then after this, I think we'll try to optimize this to find out better solutions. Okay, so we will need a for I in range or length of our list, and for j in range length of our list, in range I plus 1 to the length of our list. All right, so there are double for loops, and then in here we'll be checking to see if nums of I plus nums of j equal target. So if nums of I plus nums of j equals our target, then we want to just return its indices within a list. So just like that. And I think that should be it. Let me just run the code to make sure it gets accepted, and it does. And let's just go ahead and add some more test cases here. I think we'll just do something like 1, 2, 3, 4, and I guess the second line will equal the target. So the target here would be 5, and that will give us an indices of 0 and 3. Make sure that's right. Solution either does not exist or is not unique. Let's just take a look. How does this work? Try that. That doesn't make any sense. Just copy this. And instead of 9, let's go with 18. and that will give us 1 and 2. All right, so it did give us 1 and 2. I'm not sure why the first my test case didn't generate error out somehow. Anyways, it looks like it's working, so we'll just continue on here. So like I said, this is, I'll just put a hint here, comment here. This is a O of n square times complexity, and then space, because we're not creating any more like data structure to contain any extra memory. So this space complexity would be constant of 1. Oop. All right, so again, this is a brute force. Oop. Brute force solution is probably not the best one, so you probably don't want to do that. Let me go ahead and comment these out too and come up with a better solution here. So there's a way that we can actually just use one for loop and still get our results, but we have to kind of sacrifice space for more speed. What that means is that we need to create like a hash table to contain our index, our key and index, our index and value pairs within the hash table, because the lookup time is constant for hash tables, and the hash table in Python is a dictionary. So we have to create a dictionary that contains the index and its value, but because we have the hash table as our lookup, the speed is constant and it's faster. We can do it within the one iteration of our loop versus the nested for loop solution up here. So this, I believe, trading space for speed is, well, it depends on how big your data set is, but it's probably going to be large data sets to loop through, and I think speed is actually more important now, because space is pretty large now out there. You can you have a lot of the databases that are I mean, a lot of machines or computers out there that can store a lot of data. So I don't think space is as important as time these days. All right, so let's go ahead and come up with a better solution here. So first we need our hash table. So we'll create one. I'll just call it lookup, and it's a dictionary. And then we can then do our loop and utilizing the enumerate function, built-in function of Python, which will give us its indexes and its value. So for I, v short for value, in enumerate our list, and then here we can store like a we can create a value to store our complemented value that we're looking for. So we can call it answer is equal to target minus target minus the value. That would be our answer. So then here, if we can do a check now, if answer not in our lookup table, then we want to add that to our hash table. So lookup v is equal to the index, and otherwise we did find our answer. So that at that point we're just gonna go ahead and return it immediately, which is we return a list that has the lookup, lookup for the keys of the answer, and then whatever I is. And I believe that should be it. Let's go ahead and run this code to make sure it works. Oh, okay, so it's outputting nothing. I must have made a silly mistake here by not having the, I don't know why it overwritten my other words there. So I'll just type it again. And okay, so that worked. All right, so this solution is gonna come up with the time complexity. I'll just go ahead and type it out here. Time complexity is equal to it's gonna be O of n linear time, and then space complexity is gonna be so this is the downfall of using these solutions, but I think is a better solutions because I value time over space in most cases. So this is going to be O of n space as well. Because we need to create a hash table that stores n elements of basically values in our hash table here. So that is the trade-off, and that is the answer. Okay, let's go ahead and submit this code, make sure everything's checks out. All right, it got accepted here. So the runtime it took 48 milliseconds, faster than 79.51% of Python 3 online submission for 2 sums. Memory usage is 15.1 megabytes and less than 5.34% of Python online submissions. Okay. All right, and yeah, that should be it, guys. I'll see you guys in the next tutorial. If you guys like what you guys are seeing, please help my channel out by subscribing and giving a like. And yeah, I'll see you guys later. Bye bye.